Welcome back to our ongoing exploration of very important aspect in mechanical engineering in broader topic acoustics, environmental science, understanding and navigating the world of science. Specifically, we will be focusing on Unit 4.4, which delves into essential components of noise rating. Established standards used to measure and assess noise level, various regulations put in place to manage and mitigate noise pollution. This is going to be very easiest and important lecture. I am going to teach you. I am Dr. Sindhamari Karnal, Associate Professor in the Department of Mechanical Engineering at SVC. So get ready to delve into intricacies of decibels, learn about key noise standards, understand regulatory frameworks that shape how we address noise in various environments. Let's move on to lecture and begin our exploration of noise ratings, standards and regulations. Now we see into the realm of noise management. It is essential to understand the fundamental role and standards and key database. Regulation and standards aren't just abstract concepts. They are the practical framework that guide the design of quieter equipment and creation of safer and more comfortable workplace. Consider for instance European Union Directive 89/392. This directive underscores the importance of designing machinery with primary goal of minimizing noise hazards directly at the source. This proactive approach far more effective than simply trying to mitigate noise after it's generated. Building upon such directive noise emission declarations, we are often based on European Union directives like 86/88, then 86/392, provide crucial information to potential buyers. These declarations empower purchasers to make informed decisions, selecting quieter machines that not only contribute to a better working environment but also facilitate compliance with safety obligations. On a broader international scale, standards like ISO 11690 actively supports these goals by fostering global noise reduction efforts. This presentation will explore the comprehensive framework of these standards encompassing machine-specific safety standards, principles behind effective noise reduction devices, and an overview of the current state of noise emissions from various types of machinery. Understanding these standards and data they generate is paramount in our quest for effective noise control. The framework standards for noise measurements and machines, it's going to be very important work that governs how we accurately measure noise emitted by the machines. This is critical step in ensuring fair comparisons and effective noise control strategies. The determination of sound power, it is a key metric for characterizing total acoustic energy radiated by a machine. Primarily follows ISO 3740 series of standards, especially ISO 3744 and ISO 3746 are important. These standards meticulously specify measurement surfaces, precise locations of measurement points, necessary environmental corrections to account for the testing environment and underlying principle of uncertainty in the measurements. This ensures standardized and rigorous approach to quantify sound power outputs. Complementing sound power measurement are the emission sound pressure levels, which are measured according to ISO 11201 to ISO 11204 series. These standards occurs focus on the sound pressure at specific operator or bystander positions. Notably, ISO 11204 provides detailed method for precise environmental correction, enhancing the accuracy of this measurement. Additionally, ISO 11203 offers a valuable approach for calculating emission levels directly from the sound power data, which can be particularly useful for smaller machines. As you can see in the key standard sections, the core standards B discussed include ISO 3704 series, ISO 4871, ISO 7574, which provide further guidance and specifications related to noise emission declarations and acoustics of machinery and equipment. Ultimately, fundamental purpose of this framework standards, as highlighted, is to ensure reproducible and precise noise emission declarations. This is vital for both manufacturers who need to accurately represent the noise characteristics of their products and also for buyers who rely on this information to make informed purchasing decisions and comply with relevant regulations. Now, focus on the practical output of these measurement standards. Noise emission declarations. These declarations, which are mandatory in Europe, serve crucial tool for evaluating the noise quality of machinery and driving noise reduction efforts right at the source. They provide essential data that underpins accurate noise impact forecast and effective planning of workplace noise control measures. As outlined here, these declarations are comprehensive documents. These typically include key information such as specific machine model, operating conditions under which the measurements were taken, measured a weighted sound power levels which account for human hearing sensitivity, emission sound pressure levels at designated operating positions, and importantly, associated uncertainties in these measurements. ISO 4871 standard provides specific examples of how this information is presented. The key components you can expect to find noise emission declaration is highlighted here. These include clear machine identification, measured noise level themselves, uncertainty values associated with those measurements, which provide an indication of reliability of the data and the specific operating modes of the machine during the testing. Benefits of these noise emission declarations are significant. Firstly, they create a market stimulation for quieter machines. By providing transparent noise information, buyers can actively choose quieter alternatives. Secondly, this declaration greatly facilitates compliance with safety obligations and regulation related to workplace noise exposure. By having access to standardized noise data, organizations can better assess and manage noise risk for their employees. Beyond the general framework standards, we also have machine-specific safety standards that include dedicated sections addressing noise-related hazards. These standards are crucial as they provide targeted guidance for recognizing and avoiding noise hazards associated with particular type of machineries. ultimately contributing to improved machine safety overall, aligning with both European and international directives. These safety standards typically features specific noise reduction measures that should be considered in the design process, clearly defined noise emission values that the machinery must meet, and importantly, verification procedures that reference achievable emission levels. These procedures often follow principle outlined in the standards like ISO TR 11681, ISO 11689, ensuring a consistent and evidence-based approach to noise control in machine design. Noise reduction measures encompass design and engineering approaches implemented to minimize noise directly at the machine source. This proactive strategy is the most effective way to control noise and should be a primary focus in machine development. Noise emission values section emphasizes the importance of the measurement, declaration, and verification of noise emissions to ensure compliance with established standards. This provides a clear benchmark for manufacturers and users alike. Finally, verification refers to the procedures put in place to confirm the effectiveness of the implemented noise reduction measures against the relevant standards. This ensures that the design efforts translate into tangible reductions in noise emissions and contribute to a safer working environment. Now, shifting our focus from noise measurement to noise reduction, we have framework standards that guide the planning and design of inherently low noise machines. ISO TR 11688 series, specifically Part 1 and 2, provides a structured approach encompassing various stages from initial design task and concept phase right through detailed design and prototype investigations. To achieve this lower noise emissions, noise control devices such as silencers, enclosures, and absorbers are often integrated directly into the machine design. The effectiveness of this measure is then reflected in the resulting noise emission values. Further, to aid this investigation process, CAD, compatible examples, and computational methods are highly used to support seamless incorporation of noise control features into the overall machine design. The ISO TR 11688 framework essentially outlines a systematic process for designing quieter machines. It begins with design start specification, where relevant standards, current state-of-the-art in-noise reduction, and specific noise requirements for the machine are clearly defined. Next, in the concept phase 2, here problem-solving principles related to noise control and fundamental acoustics of the machine are considered to develop initial design concepts that inherently minimize noise generation and propagation. Following that, the third phase is detailed design. This stage involves detailed calculations and creation of precise engineering draft that incorporate chosen noise reduction measures to the machine construction. Final phase is prototype investigation. This is very crucial step, involves actual measurement and evaluation of prototype noise emissions. These measurements are then rigorously compared against initial noise requirements to verify the effectiveness of the implemented noise reduction strategies. This iterative process ensures that the final machine design meets desired noise performance levels. Let me see about standards that specifically addresses the noise control devices and materials. These are the tools in our acoustic toolbox such as enclosures, absorbers, silencers and buffers. As you can see, there are dedicated ISO standards for each of these categories. For enclosures, which aim to physically isolate the noise source, relevant standards include 11546 and ISO 11957. For observers which work by dissipating sound energy, we have ISO 11654 and ISO 10534. Silencers designed to alternate airborne noises covered by ISO 7235 and ISO 11691 along with ISO 11820 and 14163. Finally, for noise buffers, which are often used to break up sound path and reduce reverberation, relevant standards are ISO 11821 and ISO 100534. This section provides a visual representation of these key noise reduction elements. We have enclosures with the associated ISO standards aligned with the specific ISO designations. Then we have silencers aligned with a slightly longer list of relevant standards reflecting the complexity of the design and application. And finally, we have buffers with the corresponding ISO standards. Let's take a look at the current state of noise emission from various types of machines. ISO 11689 plays a key role here, as it describes the methodologies for the collection, presentation, and evaluation of noise emission data. This standard helps in defining different emission groups, relevant emission values such as sound power level, emission sound pressure level, applicable measuring standards, and the criteria for data representativeness. Effectiveness of noise control performance is often assessed using emission values, sometimes denoted as L1, L2, L3. Generally, lower values indicate better noise control. For instance, German VDI-ETS guidelines provide specific emission data for various machine groups, offering valuable benchmarks. Examples include woodworking machines, metal cutting machines, giving us a snapshot of typical noise emission ranges in these sectors. This table provides a glimpse into the typical emission values ranges for a few common machine groups. For woodworking machines, the emission values typically ranges from 83 to 105 decibel. Metal cutting tools also exhibit a range of approximately 82 to 105 decibels. Finally, RIC engines, reciprocating internal combustion engines, shows a comparable emission range of 82 to 105 decibels. It is important to remember that these are general ranges and the actual noise emissions of a specific machine will depend on its design, operating conditions, and any implemented noise control measures. This data highlights the significance of underlying and understanding, also applying the standard we have discussed to effectively manage and reduce noise pollution from machinery. Let's zoom in on specific type of machinery, surface planning machines. Here it is BDI 3740 Part 2 provides Valuable noise emission values, specifically a weighted sound power level or LWA for these machines. These values are categorized based on factors such as cutting tool width and operating state of the machine. As you can see, noise emission values for surface planning machine ranging from 82 decibel to 105 decibels. This variation depends on several factors including specific type of machine, width, width of the cutting tool, crucially whether the machine is operating under load, meaning it is actively machining material, or it is running under no load conditions. This specific emission value provides a more granular way to compare the noise control performance within its particular group of machines. We can observe that the machine type considered here include surface planer with a cutting width of less than 400 mm and planning machine with a 400 mm cutting width. Operating states are categorized as either no load, meaning the machine is running but not cutting or machining, when the machine is actively engaged in a material removal. Across these different machine types and operating states, overall emission range is consistently reported as 82 to 105 decibels. This underscores the importance of considering both machine specification and its operational mode when assessing and comparing noise emissions. As we reach the end of the noise rating standards and regulations, let's take a moment to summarize the key takeaways. Firstly, we have seen that standards and regulations are absolutely essential in our effort to reduce noise hazards originating from machines. They provide a crucial framework that guide the entire process from the initial design considerations to the accurate measurement, clear declaration, and thorough verification of noise emissions. Secondly, we have highlighted the importance of machine-specific safety standards and structured noise reduction frameworks. This supports the creation of safer and quieter workplace by providing targeted guidance for different types of machinery and outlining systematic approaches to minimize noise generation. Further, we have learned that noise control devices and materials themselves have dedicated standards that ensure their effectiveness in attenuating sound. Finally, we have explored how current noise emission data and associated guidelines are vital for benchmarking the noise performance of different machine groups. This data enables us to compare noise level, track progress, drive continuous improvement in noise control performance across various industries. In essence, comprehensive understanding and application of these noise ratings, standards, and regulations are fundamental to create healthier and more productive work environment by effectively mitigating the risk associated with excessive noises. Thank you again for engagement throughout this lecture. If you have any further questions or want to delve into specific aspect in more detail, don't hesitate to ask. We will see in the next lecture.